Welcome to today's lesson. I am Siamasaka Kilian Dens. Today we are going to look at how we can balance nuclear equations. So we go straight into the lesson. Well, balancing of nuclear equations, we will look at how we can balance nuclear equations for alpha decay, Actually, alpha decay is a helium nucleus with the nucleon number 4 and the proton number 2. So meaning that actually there are 2 protons and 2 neutrons. And so during the decay process, the protons actually decrease by 2 and the nucleon number also decreases by 4. In other words, if you have the atom denoted by nucleon number A and the proton number Z, and it decays, it has an alpha decay, it simply means we are going to form a helium atom with a nucleon number 4, atomic number 2. And being that here, the nucleon number should, as we said, decrease by 4, while the proton number should decrease by 2. For example, if you have the element or the atom with a nucleon number 238 and the proton number 90, meaning that you form a new atom with a nucleon number which is going to decrease by 2 and the proton number which is going to decrease by a nucleon number which is going to decrease by 4 and the proton number which is going to decrease by 2. So you're going to have your helium atom, the nucleon number 4, and then the proton number 2, meaning that to 238, we need to subtract 4. So we remain with 234. 234. And actually the nucleon number for the proton number for this one was 92. Okay, 92. For the actual atom, it's 92. That's the proton number. And so we expect that the proton number is going to decrease by 2. So you are going to subtract 92 minus 2, which actually gives you 90. So this is how. And so when you add the nucleon numbers for the new atom plus the one for helium, should be able to give you the overall nucleon number for the original actually atom. And so the other example is for an element AM with the nucleon number 241 and atomic number 95. So this is an alpha decay. what will happen is that you produce a new atom plus the helium atom with the nucleon number 4 and atomic number 2. And so this one, the new atom will decrease actually by 4 on the nucleon number, which gives us 237. 237. And then the proton number is also going to reduce by 2, which is actually 93. Another element is actually this atom here with the nucleon number 236 and the proton number 84. When there is an alpha decay, you are going to produce the helium atom with the nucleon number 4 and atomic number 2. And then you have the new element where the nucleon number is going to decrease by 2. So it's going to be 236 minus 4, which will be 232. And then 84 minus 2 for the proton number, we're going to have 82. So really, this is how an alpha decay actually takes place. So we'll go on to look at the beta decay. For a beta decay with this symbol, actually it is an electron which is moving with the high energy, with the nucleon number 0 and the proton number which is -1. So it's an electron here, it's an electron. So the proton number will actually increase by 1, and then the nucleon number stays the same. Otherwise, what we are saying is that, for example, A is the nucleon number and Z is actually the proton number. So when there is beta decay, we are going to have a new atom with, if you subtract A minus 0, it gives you actually the same nucleon number to be maintained. And then the proton number is going to increase by 1, because we're going to say Z minus -1. Then you're going to actually add the electron. So in other words, this one gives you A, Z, and then the new element is going to have the same nucleon number, and we're going to add 1 to the proton number, because -1 multiplied by -1 here, it gives you actually positive. Then plus the first moving electron. So we'll give now an example. For example, if you have an element, an atom, which undergoes actually beta decay. So the nucleon number is 16, and then the proton number is 8. So when it undergoes beta decay, you are going to form a new element with the same actual nucleon number. And as we said, the total number is going to increase by 1, which will be 9 plus the electron actually with the neutron number 0 and that one. So this is how you go about it. Another example for a beta decay, if you have an element, an atom here, neutron number 2, and then positive 1 as the proton number. So when this one undergoes actually a beta decay, you are going to have, you maintain the same neutron number, and then this one increases by 1, meaning that we're going to have 2 plus the electron. Similarly, if you have another element, another example with the neutron number 63, and then 28 as the proton number, it undergoes beta decay, you're going to have an element where you are going to maintain actually the same, because this is actually a beta decay. So you're going to maintain the same nucleon number, and this one is going to increase by 1. And so what we're going to have is actually this plus the electron. So I thought today we can look at how we can balance actually equations, nuclear equations, where there is a beta decay as well as the alpha decay. Thank you.